Alright, so I'm going to walk you through the basic steps for solving these sine of a sum or difference, cosine of a sum or difference, and tangent of a sum or difference problems. So here, the first one is sine of 15 degrees. So we have to think about some angles that we know from our unit circle and from our table of values that will either add or subtract to 15. So right off the bat, we can see 45 minus 30 will give us 15, and also 60 minus 45, and we could go on and on with this, but we typically want to stick with the ones that are in the first quadrant that are on our chart. So we can start with 45 and 30. So I'm just going to do the sine of 45 minus 30, and from here you're just plugging it into the identity which you're going to be given. So sine 45 cosine 30 minus, it's a difference, so the minus stays for the sine, and then we have cosine 45 sine of 30. From here, we're just going to go from our table of values and plug in. So sine 45 is root 2 over 2. Cosine 30, root 3 over 2. And I'm just taking these from my table. Root 2 over 2. And sine 30 is 1/2. So we just multiply. We can multiply radicals, but we cannot add them. So root 2 times root 3 is root 6. Minus root 2 over 4. And that's going to be our answer. So this really is not all too complicated, especially when you have values that are in your first quadrant. So next is cosine 105. Again, the first step, we just want to find two angles that add up to 105 that we're comfortable with. So we could do 60 plus 45. That'll equal 105, 135 minus 30. We could also use, but like I said before, we want to use things that we know. So 60 and 45 are both on my chart, so I'm going to use those two. So cosine 60 plus 45, and I'm just going to plug that in to the formula. So cosine 60, cosine 45. Now this is cosine, so if the sign is going to change, minus sine 60, sine 45. And once again, I'm just going to go for my table of trig values that we use. Cosine 60 is 1/2. Cosine 45, root 2 over 2. Sine 60 is root 3 over 2. Sine 45, root 2 over 2. Then we just multiply across, and you end up with root 2 minus root 6 over 4. And that's our answer. Notice again, we have a root 2 with root 6 and a 4. So you should be starting to notice some commonalities between the answers for these types of problems. So this kind of takes it to the next level of difficulty because we're going to have to use angles that are not on our chart. So what we want to do is think of angles in the third quadrant or the fourth quadrant that can add up to 255 that we know the reference angle for. So remember, the reference angles we know are 30, 45, and 60. So I know that 225 is in the third quadrant, and that has a reference angle of 45. And then I could do plus 30. You could also do 300, which is in the fourth quadrant with a reference angle of 60, minus 45. Either of those would work. I'm going to stick with this one here just because I like addition. So I'm going to plug it in. Tangent of 225 plus 30. And I'm just going to plug it right into the formula. So tan 225 plus tan 30. The sign stays the same in the numerator, and then in the denominator it's going to be the opposite. So 1 minus tan 225 tan 30. So to find the tangent of 225, you know we have 0, 90, 180, 270. So it's got to be somewhere in here. And the reference angle is always to the x-axis. So this is what we're looking for. So all you're going to have to do is 225 minus 180, and you get a reference angle of 45. Some people know that, some people don't. And the last thing we want to know is if tangent's going to be positive in that quadrant. So we have all students take calculus. You see it is in the third quadrant, which is where tangent's positive, so it's going to be positive. So tan 225, which is really the same as tan 45, is 1, plus tan 30 I just know from my chart. Then 1 minus tan 225, which we said was 1, so 1 times root 3 over 3 is just root 3 over 3, and you can just leave your answer like that. So once you get comfortable with your reference angles and where they are in each of the quadrants, this really isn't too difficult. So 345, I'll just walk you through. You could use 345. That's going to give you 300 as a reference angle of 60. You could use 315 and 30. That has a reference angle of 45. Then I think you guys could figure it out from there. That's in the fourth quadrant, so cosine is going to be positive. Tan 75, I'm going to go to one that we haven't seen yet, like this one here, cosine 7 pi over 12. This is in radians. So if you don't like radians, you could right away put it in degrees by multiplying by 180 over pi. That's one of the first things we learned. So the pi's are going to cancel, and you end up getting 105 degrees. So you could find the cosine of 105 degrees and use angles that way. But if you would like to do it in radians, you want to cut 7 pi over 12 into two things that will add up to 7 and that we know the angles for. So for example, remember in radians we know pi over 4, we know pi over 3, and we know pi over 6. So if we're in 12ths, that would be 3 pi over 12, 4 pi over 12, and 2 pi over 12. Sorry about the handwriting. It's getting worse. So you notice right away 3 and 4 add up to 7. So we can use those. So 3 pi over 12 plus 4 pi over 12, and that'll equal 7 pi over 12. So that's really that. We can simplify that to pi over 4 plus pi over 3, and then plug it in the formula. And if you use cosine 45, you probably would have ended up using 45 and 60, which are the exact same as these radians. So again, I'm just going to plug it into my formula. Cosine pi over 4 cosine pi over 3 minus sine pi over 4 sine pi over 3. And then we're just solving. So you get root 2 over 2 times 1/2 minus root 2 over 2 times root 3 over 2. And again, you'll see a nice answer, root 2 minus root 6 over 4. So we're really not getting too many different answers. All that's changing is our signs and the order that they come in. So this is the general steps you use. I went over one of each type of problem, so I think you guys will be good from here. So good luck.